Okay, so I guess like we could start by like reviewing some basic triangle like concepts. So like an equilateral triangle has three equal sides and three equal angles, which means that they're always 60 degrees. An isosceles triangle have two equal sides and two equal angles. So if you wanted to look for the two angles, then you could just essentially do 180 minus whatever the third angle is divided by 2. And a scalene triangle has no equal sides or angles. An acute triangle have all angles that are less than 90 degrees. A right angle triangle has exactly one right angle in uh and an obtuse angle has an angle that is more than 90 degrees. So an important rule to remember is that all the interior angles added together are always add up to 180 degrees. So like you could try out some of these questions. I'll give you like 4 minutes. This should be like a review. Okay, so it's been 4 minutes. So I'm just gonna tell you the angles. So for A, x for A, x equals to 70 degrees. For B, y equals to 60 degrees. And for C, and the angle Z is equal to 80 degrees. So for the second question, it's gonna it was a little bit more tricky. So essentially it's gonna be, so for A, 25 plus 45 plus 2x plus 10 would equal to 180 degrees. So essentially you're looking for x to find out what this angle would be. So essentially it would become 2x plus 10 equals to 110 degrees. So then 2x equals to 100 and x equals to 50 degrees. Oh, sorry, no, it's 50. And then in order to find that angle, you just plug x back into the 2x plus 10. So you would get, it would be 110 degrees. So this angle that is 2x plus 10 is essentially 110 degrees. So for B, it would be x plus 2x plus 60 degrees equals to 180 degrees. So 3x would equal to 120 degrees. So then x would equal to 40 degrees. So then you plug this back into the 2x. So you get 80 degrees. So this angle would essentially be 80 degrees. And this angle would be essentially 40 degrees. And then for C, it's the same thing. It's just 20x plus 10x minus 5 plus 17x minus 3 equals to 180 degrees. So that would essentially be equal to 47x minus 8 equals to 180 degrees. So then 47x equals to 188 degrees, which means x equals to 4. So if hang on a second, just I'm gonna erase this. Okay, so I'm gonna continue over here at the top. So essentially you plug in the numbers into the expression. So you get what this angle equals to 80 degrees. 17x minus 3. Sorry, 17x it would be 17 times 4 minus 3, it would equal to 68 minus 3, which equals to 65 degrees. And then you have 10x minus 5, which equals to 10 times 4 minus 5, which is 40 minus 5, which equals to 35 degrees. So you have 80 degrees, 65 degrees right here, and 35 degrees over here. So any questions?
I think we understand.
Okay. So another basic information. So the perimeter, to find the perimeter of a triangle, it's you essentially just add up the 3 sides. There's like no specific formula for it. For the area, you essentially just times the base and the height divided by 2. Um, but however, there's like another way you could find the area, which is through this formula, called the Heron's formula. So essentially, you could find the area, through this formula without like when you only know like the three side lengths of it. So like square root of p times p minus a times p minus b times p minus c, where p is half of essentially the perimeter, because this is the same as this. So um yeah. So you could give these questions a try. I'll give you like 5 minutes because there's a little more. Okay, so time's up. Uh, so so for the first four questions, it's really simple. You just use this formula. So uh, so for I'll just show you for like the first two, and then just tell you the answer for the last two. It's essentially half times base times height. So you have half times 8 times 6, which equals to half times 48, which is 24 centimeters squared. For B, it's the same thing. You have 7 as the base and 12 as the height. So B half times, I think that's 84, which means it'd be the area would be 42 millimeters squared. So I'll just tell you the answer for these two. So C is 22.5 centimeters squared, and D is 26.25 meters squared. Um, so for E, you're gonna have to use Heron's formula, which is right here again. So essentially, you first need to figure out what P is. So if you just plug in the numbers, you'll get P equals to half times 14 plus 6 plus 10, which means P equals to half times 30, which equals to 15. So, and then you essentially write the formula out first. And then plug in the numbers. So you have 15 times 15 minus 14 times 15 minus 6 times 15 minus 10. So that equals to 15 times 1 times 7 times 5, which equals to square root of 525. And if you put that into a calculator, you get it it's approximately 22.9 centimeters squared. So any questions for this one? Because I need to erase for the next one.
Yeah, we're good.
Okay. So um so for this question, you get the perimeter and then 2 of the sidelines. So as I said before, it's P is essentially half of the perimeter. So with this condition, you could already get P as half times 42, which is 21. However, you need like the third sideline to fill in for this formula. So essentially what you could do is 42 minus 14 plus 18. So that would equal to 42 minus 32, I think. Yeah, so then that equals to 10. So if you plug that into the formula, you get 21 times 21 minus 10 times 21 minus 14 times 21 minus 18. So all of that would equal to the square root of 21 times 11 times 7 times 3, which is the square root of 4,851, which is, if you put that into a calculator, it's approximately 69.6 centimeters squared. So does everyone understand? Because I need to erase that again.
Yeah, we're good.
Okay, so for the last question, you're given that the triangular park the sides are have a ratio of 12 to 7 to 25. So um I guess you could like sort of like draw it out. So like you'd have um something like this, I guess. Sorry, something like this. Um and you'd have like this. So if we all put this into one unit, you'd have something like 25x, 17x, and 12x. Um, so you know that the perimeter is 540 meters. So the same thing as this question, you could say like 17x plus 25x plus 12x uh equals to 540. So that you get 54x, sorry, equals to 540. So then you could get that x equals to 10. So if you plug x back into all of these, you'd get 12x equals to 120, 17x equals to 170, and 25 equals to 250. So through all of this, you could right now you have all the numbers to plug into Huron's formula. So you have first of all you need to figure out P, which is half of the perimeter, which you know. So it's that. So that means the P is equal to 270, and then um if you plug in the formula, you get 270 times that 270 minus 250 times 270 minus 170 and 270 minus 120. Um, so I'm not gonna write like I'm just gonna go directly to the product, which is I think that's 81 million. Uh, yeah, so square root that and you get 9,000. So therefore the perimeter, sorry, the area of the park is 9,000 meters squared. Any questions?
No question.
Okay. Okay. So, a few other ways that you could like have like use the area is like questions like this. So, given that the triangle ABC is the area for triangle ABC is A, and that D and E are two medians, what's the area of DEF? So, um, you could try this question, I guess. I'll give you like 2 minutes. Okay. So, uh, right now, you could see that, so let's say, this is the height for, the large triangle ABC, and this is the base for triangle ABC. So if I say that, I'm gonna say that this is uppercase H and this is uppercase B, and uh, this is the height for DEF, and this is the height for, sorry, this is the base for DEF. And if I say that, this is lowercase h and this is lowercase b, so since D and D are like two medians of AB and AC, uh, you know that, uh, H is essentially, essentially, wait, sorry. Um, Lowercase h is essentially half of uppercase H, and lowercase b is essentially half of uppercase B. So, um, if you want to find the area of DEF, so using the area formula, you get, you do base times height divided by 2. But since lowercase h and lowercase b have, you could plug in these numbers. So that would be half of b and half of h. So that way, you know right now that that would be half of h, sorry, b times h. So if you say that triangle ABC's area is A, then that means the area of DEF is 1/4 of A. So any questions?
We're good.
Okay. So moving on. So for this question, I could, like, I think I'm gonna run out of time, so uh you could like try maybe the first question, but I'll give you like 2 minutes to try these questions, but I'll just like go through it really quickly. Okay. So I'm just gonna go through this really quickly. So given that GHIJ is a rectangle, and K is the median of GJ, and LJ is 1/6 of GJ. The area of triangle KHI is A. What is the area of the triangle LHI? So you see that the height for KHI is and the base for KHI is essentially the same thing as LHI, since so it's sharing a base and it's also sharing a height, which means that the area of KHI and LHI is essentially going to be the same, since it's like sharing the same base and the same height. So if they say that the area of triangle KHI is A, then the area of the triangle LHI is also going to be A. And then for question 2, it says given that GHIJ is a rectangle where the area is equal to A, what is the area of the triangle LHI? So for the area of a rectangle, it's essentially just base times height, right? So uh and for the area of triangle, so you see that for rectangle GHIJ, the height and the base, it's also the same as LHI. But just be careful that the area for a triangle is half of base times height. So if if the area for the rectangle is equal to A, then that means the area for the triangle is going to be just half of A. So does everybody get that?
Yeah.
Okay. So um so this is like similar triangles. So two triangles can be like similar when their angles are like all the same, and the sides that they each correspond to are all like proportional to each other. So like for this question, if the PM is 3/4 of MN, and MQ is 3/4 of MO, and the area of the triangle MNO is A, so then what's the area of MPQ? So since you know that PM and uh MQ are like all proportional to MN and MO, you and they're like all 3/4. So essentially then the area would also be would also be the same. So um the area for MPQ is going to be 1/4 of whatever NO is. So it'd be 1/4 of A. Does everybody get that?
Yeah, we get it.
Okay. Um, so this is a similar case to the one above. So essentially, uh since UT and like ST, so sorry, SU and UT are like proportional. And since they share the same um height, then that means SU triangle SUR is similar to the triangle URT. Does that make sense?
Yeah, we get it.
Okay. So I guess you could like try I guess try the first question. I'll give you like 3 minutes, try the first question, and then I'll explain it. Okay, so time's up. So essentially you're told that the area um of a triangle that has the side lines 25, 25, and 30 is A, and the area of a triangle that has the side lines 25, 25, 40 is B, and you want to know what the relationship between A and B is. So um essentially you could just find like you could just like sort of like find the area um of these two triangles using Kieran's formula. So like if you plug in the numbers, so you know that P is going to be equal to, for this one, you know that P is going to equal to 40. If you just add them up, they're all equal to 80, and then you divide by 2, it's 40. And then for this one, you know P is going to be equal to 45. So add them up, you get 90, and divided by 2 is 45. So for A, it's going to be 40 times 40 minus 30 times 40 minus 25. Sorry, times 40 minus 25. So I'm not gonna go through like all the calculation, but essentially you're just gonna get 90,000, which is equal to 300. Square root of 90,000 is 300. And then same thing for the second triangle, you're gonna get 45, 45 minus 40, 45 minus 25, and 45 minus 45 minus 25. Um, and you'll also get the square root of 90,000. So essentially, if this is A and this is B, then A equals to B. So your answer is going to be C. Does that make sense?
Yeah.
Okay. So you could try this question. Uh, I'll give you like 4 minutes to try this because this is a little trickier. Okay, so um you're given that the area of this triangle is 8 inches square, and that A and B are midpoints of X, Y, and XZ. And you're also given that XZ bisects YZ. So from that, you know that XZ is the height for this entire triangle, and you're asked to find the shaded region. So first, like we could go with like this condition over here. So you could say like, so you know that half of base times height is the area, and you know that the area is equal to 8. So the base, we could like replace these two variables for y z times xc over 2 equals to 8. So that means yz xc is equal to 16. So yeah, so we'll get to this condition later. But the next thing you know is that since xc bisects yz through like similar triangle, you know that the triangle xyc is congruent to xcz. So that means the area of xyc is half of xyz. So you know that the area for xyc is going to equal to 8 divided by 2, which is 4. So in order to find the shaded region, you're essentially subtracting 4 by whatever this is over here. And to figure that out, we could set like the points of intersection over here as D, and say, we know that XAD is similar to XYC because like all the angles are the same, and the side lengths are proportional. So in order to find XAD, you're essentially doing XD times AD divided by 2. But you know that this side length over here, XG, is equal to half of XC. You know that AB is exactly and you know that AD is 1/4 of YC, so essentially AD. So if you look at it from like this, so AB is half of YZ, and since AD is equal to half of AB, then that means half of AB is equal to 1/4 of YZ, since you multiply 1/2 on each side. So AD could replace this as YZ, 1/4 of YZ divided by 2, and you would get 16 over XC times YZ, and then you could just replace this in here, so you get 16 over 16 equals to 1. So you know that triangle XAD is equal to 1. So the shaded region would be just 4 minus 1, which is 3. So your answer is D. Does that make sense?
Yeah, we good.
Okay. So so some congruences, you could just say like, in order to figure out like if a triangle is congruent or not, you could just say like, are all the, so there are like, I think there's 3 different types. There's like side to side, which is when all of the side lengths are like equal, then you know that it's congruent. So like for example, for this example, you're given that DC is the same as DA and AB is the same as CB. And you also know that and they share the same side, which is EB. So and since like that has to be the equal, then that means then triangle DAB is congruent to triangle DCB. Um, and then the other type of congruence is like side angle side congruence, which is where like there's two angles that are, I'm sorry, two sidelines that are the same and one angle that is the same. So through that, you could also know that the angle of the triangles are congruent. Um, and there's also the hypotenuse leg congruence where you could say, or you could say like, since you know that there's always going to be one right angle that's going to be equal. So if if the hypotenuse and then another leg of a right angle triangle is the same, then you know that the two triangles are congruent because of the 90 degrees. They share the same angle and two same sides. Um, and then the last type of congruence is like when you know two angles and one side length of a triangle, and if they're all equal to the other, then you know that the two triangles are congruent. Um, so I'm just gonna go through this really quickly since I might go over time. But for the exterior angle theorem, it's essentially where so this is the formula for it. But you could also think of it as like um if angle, so like let's say this side is like x, then you know that this entire angle is 100 degrees, so c plus x would be 180 degrees. But also a plus b plus c is also 180 degrees. So if you switch this for like this and subtract c from both sides, those cancel out. So then you get x equals to a plus b. So you could think of it like that as well, if you wanted to. Um, but you could really quickly try these questions. Although I don't know if we have time. So like I'll give you like 2 minutes. Um, okay. So I'll just like I won't go through the calculations because I'll just tell you the answers. So for this one, x would equal to 150 degrees. For b, y would equal to uh 70 degrees. For c, angle z would equal to 50 degrees because 45 plus whatever this is equal to 95. So then subtract 45 for both sides and you'll get 50. D, just a reminder that this is an isosceles triangle, which means this angle and this angle are equal. So if you know the top angle, you can figure out this angle through 180 minus 80 divided by 2 equals to 50 degrees. So then 50 plus 80 would be 130 degrees. So x equals to 130 degrees. And y, same thing as question C, y would equal just 20 degrees.